Hi everybody. Today we are just going to do what I call micro lesson. Micro, very small one. Okay, very fast and sweet one. Like maybe a few minutes I finish the lesson already. Okay. So let us try to sketch logarithmic graphs today, and we are just going to do one example for this particular micro lesson. Okay. So take a look. Sketch y equals to log of e to the power x. Now, if I were to interpret this log e to the power, y equals log x, right? It actually means, log means base 10, right? So it actually means 10 to the power of y equals to x. Okay, so you can either sketch this graph or you sketch this graph. The overall result is the same, okay? But for this particular micro lesson, I'll just show you how we sketch this log graph, all right? Now, let's say I ask you to sketch this log graph. The intuitive thing to do, since sec 1 you've been taught, right? You draw a table of values, okay? So I have certain x values here, and I want you to find the y values. You can pause the video and do that, okay? After you've done that, then you play the video again. Okay, now assuming you have already done whatever I asked you to do, now you will notice that when you log negative numbers, the calculator will tell you that the answer is inadmissible, or there's math error. Okay, so for example, I log of -5, I will get error, right? Okay, so this ties in very nicely with our uh, definition, which I asked you to know very well last night, or was it yesterday? Okay, that the argument y has to be positive. Okay, that's the first condition. Number two, your a cannot be 1. Okay, and it must be greater than 0, because if it's negative, right, then you will the log function will not be defined. Okay, this one we'll discuss next time. Then if it's 1, if it's 1, right, 1 to the power of anything will still be 1. So you will not get a definite answer here, the index here. So that's why it's also not defined if your base is 1. So you have to remember these conditions very well. Otherwise you will be quite lost. Okay, so let's come back to the graph. So we know that negative numbers doesn't work. So you cannot sub in any negative value to this graph. It's not defined. Okay, how about 0? When x equals 0, when you log 0, what do you get? You go and log 0, also cannot. Why cannot? We already mentioned that your y must be greater than 0, which means that you see, why is that so? Okay, instead of memorizing, it's good to understand. Okay, you see, a number raised to any number can never be 0, you see. Even you put this index as 0, right? A to the power of 0, anything to the power of 0 is 1. So you can never get the argument here as 0. That's why y must be greater than 0. It cannot be 0. Okay, so this one also cannot make it. You can go and press calculator and try for yourself. Okay, so if you were to press log 10, you will get this. I already worked out. So you go and check whether these are the answers. Okay, so I've rounded them off to 3SF, but I want you to notice something. I know with these values you can easily plot your graph, correct? That's what you've been exposed to since sec 1. But I want you to notice that as the x increases, as x increases, right? You see, 10, 20, 30, 40, 50, 60. Of course, there can be values in between, but I'm just taking the range, the difference of 10 here. Okay, so as x increases, what do you notice about the y values? Do the y values increase or decrease? So the y values increase, right? Increase. But they are increasing. You see, this one is plus 0.3. This one is plus 0.18. This one is plus 0.12. So it's increasing lesser and lesser, right? Then this is 0.08. Okay, do you all know what I mean? It's increasing. Yes. As x increases, y increases. Okay, you see? This one is greater than this one, greater than this one, greater than this one, greater than this, right? But it's increasing in a decreasing trend. Okay, there's a difference. We'll discuss more next time. If you don't understand what I'm saying, you hear me. Okay, which means that this is a graph that is not a straight line. Okay, it's not a straight line. It is a graph that is, you see, we have learned that time in this one kinematics, something like kinematics, that if it's increasing constantly, then it's like that, right? If it's getting more and more and more and more, then it's like that, right? This is called increasing. But this one is increasing but in a decreasing fashion. Okay, so the graph actually looks like that. You can go and plot. You can, you don't believe me, you can go and plot. You can go and label here as 0 then 1. Okay, let's label this as 1, and then this one is 2. Okay, so you can go and plot, but the graph, right, generally will look like that. Okay, something like that. Okay, of course our values are all here. This one is not drawn to scale, but the graph, right, will look like that. You can use Desmos to check for yourself. And the very important thing that you must show, right, is that this x-axis this y-axis is the asymptote, meaning you go closer and closer and closer, but you will never touch the y-axis here. Okay, so this is an asymptote. Okay, and can you work out what this value is? Now you know for certain here that the y value is 0, right? Okay, so you can sub in here, or you can sub in here, because these two are equivalent. So the y value is 0, then your x is equals to 1. Okay, or you can think of it as this one means log base 10, right? 10 to the power of what? 10 to the power of 0, right? 10, because this y is 0, what? Okay, this is y, this is x, right? This y is 0. This y is 0. So this, when y equals 0, so this 10 to the power of 0 is your x, right? So x equals to 1, so this is 1, 0. Okay, so whenever you plot graph, or whenever you sketch graph, sketch, we're not plotting, but I was saying just now that if you don't believe, you can go and plot you can go and plot, and then roughly you will mark out all the crosses, you will find that it's of this shape. Okay, if you take any number here, right, less than 10 and all that, because 10 is somewhere far away from here, all right, this 1, 0, the 10 is somewhere beyond my screen already. Okay, so you go and try it out. Okay, so today's lesson very simple. You just remember that the log graph, right, has an asymptote here. Okay, and this point that it cuts here, okay, you will be able to find by substituting appropriate values into this equation or its equivalent form. Okay, so you go and figure out. Okay, now for those of you who are more hardworking, you can go and sketch y equals to log x minus 2. Okay, yeah, so you go and think about how to sketch this. I give you a hint. Now for this to be defined, right, for this sketch to be defined, your x, right, as we have discussed that day, your x here is your y here lah, your argument. That means your argument must be positive. Okay, your argument must be positive. That means x greater than 0. That's for this case. That's why the asymptote is this line here, x equals 0, correct? So for this to be defined, your asymptote, okay, there's a clue here lah. Your x minus 2 must be greater than 0, right? Because your argument cannot be negative, so your argument must be positive. That means x must be greater than 2. Okay, so your sketch will be, your asymptote will be x equals, I'm giving you the answer already. In fact, I asked you to go and try, right? But never mind. Okay, so your asymptote is this fella. Okay, and you have to draw it in this shape. Alright, you will get closer and closer and closer and closer to x equal 2, but you will never touch x equal 2. And what is this value? Okay, you go and work it out. Okay, so that's your homework. Okay, so that's all for this very short video. Wow, short also not short. It's already almost 12 minutes. Okay, see you tomorrow.